In example 1, we're just going to go through some information on inverses. The multiplicative identity for real numbers is 1 because for any real number a times 1 is equal to a, so the same thing that it started as. The multiplicative identity, which is an n by n square matrix, is called the identity matrix. So your identity matrix looks like the following. We call it I, and what happens is in the top left corner we have a 1, and then followed by a 0, and maybe another 0, and it's all zeros until the very end. Then what happens in our second row, we start with 0, and then we go to 1, and then we are followed by zeros. Again, all the way to the end. Then our third row, we would have 0, and then another 0, and then a 1, followed by a 0, all the way to 0 at the end. And this is going to continue as we go down. These would all be zeros. These would all be zeros here. These would all be zeros, zeros, and all the way out till our last number here would be a 1. So basically what you're seeing is you have a diagonal of 1s and zeros everywhere else. So you have all 1s on the main diagonal. And zeros everywhere else. So if A is an n by n matrix, then A times the identity matrix, or the identity matrix times A, is equal to A. So it's very similar to multiplying a number by 1. If A is a non-zero real number, then 1 over A, or A inverse, is the multiplicative inverse of A, because A times 1 over A is A times A inverse is also 1. The multiplicative inverse of a square matrix is called its inverse matrix. If we let A be an n by n matrix, if there exists a matrix B such that A times B equals B times A, which equals the identity matrix, then B is called the inverse of A and is written as A with the little negative 1 up there at the top in the exponent. So basically A times A inverse is equal to the A inverse times A, which is the identity matrix. If matrix A has an inverse, then A is said to be invertible. Oops, that's an R. Invertible. Or non-singular is another way we would say that. A singular matrix does not have an inverse. So if it's non-singular, it has an inverse. If it's singular, it does not have an inverse. Not all square matrices are invertible. To find the inverse of a square matrix A, you need to find a matrix A inverse, assuming it exists, such that the product of A and A inverse is the identity matrix. If we talk about a 2 by 2 matrix, if we let A equal A, B, C, and D, A is invertible if and only if A times D minus C times B does not equal 0. So if A is invertible, then A inverse is equal to the following formula. 1 divided by A times D minus C times B times the matrix. We take D and A and switch their spots, and we take the opposite of B and we take the opposite of C. Remember, AD minus CB, that's the determinant. So we're basically taking 1 divided by the determinant, taking that number and multiplying it to each one of these as we switch these around. Now we're going to go to example 1.